Okay, hello there, 2Ds. We are going to be wrapping up our second quadratics unit today, and we're going to be quadratic applications. I put more in brackets there because we did do some quadratic application problems in the last unit, but there's a couple different types that I want to focus on and what type of questions they ask. So let's just take a look. So today our learning goal is to solve problems involving quadratic relations. And the first type of problem that we're going to work on are flight problems. Anything to do with the path of something that is thrown or launched or anything like that is going to be modeled by a quadratic equation. So this should be of interest of anyone who's planning on taking a physics class in the future because you will see this type of question in those classes. So let's say we have a firework. It's launched from a height of 2 meters above the ground, and it reaches a maximum height of 40 meters at a horizontal distance away from where it starts of 10 meters. So we're going to be asked to do a few questions here. The first one is to determine an equation that models the flight path of the firework. The second one is if the firework continues to travel an additional 1 meter horizontally after it reaches the maximum height before it explodes, it travels an additional 1 meter horizontally after it reaches the maximum height before it explodes. So that's when it explodes, is 1 meter after it reaches maximum height. What is the height at that point? So we're going to answer that question and then see at what other horizontal distance is the firework at the same height as in part B. As you can guess, since parabolas are symmetrical, we will have two horizontal distances that have the same height, unless we're at the vertex. So first of all, let's do part A. So we're going to determine the equation, and we're going to take a look at some of the information that we're given. So the first thing, the launch height, it gives us a height, so that's our y value. You could think of height as along the y-axis, and horizontal distance will be along the x-axis. And the horizontal distance when it's launched is 0 because that's the starting point. So that's a really good tip to keep in mind. Um, if it's horizontal distance or maybe it's time on the x-axis, the starting point has a coordinate of 0 for the x-coordinate. So that gives us a point for the equation. Another thing that we can get from this information is the maximum height is 40, and that happens at a horizontal distance of 10. That tells us what the vertex of the equation is. So the vertex will be 10 and 40, which gives us h and k in our quadratic equation. So what we're going to do, just kind of like we did in the last lesson, we're going to sub in our h and k value into our vertex form of quadratic equations, and we're going to use another point to solve for a. So first, sub in h is 10 and k is 40 into our equation. Okay, there we are. And now we're going to put in our point to solve for a. So we're going to put in 0 for x and 2 for y. And now we can do the math to get a by itself. So we have 2 equals a times 0 minus 10 squared plus 40. 0 minus 10 is negative 10, and negative 10 squared is 100. So we get 2 equals 100a plus 40. We then need to subtract 40 both sides to get negative 38 equals 100a. And then to get rid of that 100, we need to divide both sides by 100. So a is negative 0.38. So now we can put our a value back into this equation here to get our final equation that models this fireworks path. So the equation is y equals negative 0.38 times x minus 10 squared plus 40. So the second equation, sorry, not the second equation, second question was the firework containers to travel an additional 1 meter horizontally after it reaches its maximum height before it explodes. What is its height at this point? Well, remember at its maximum height, the distance was 10 meters. So if it goes an additional 1 meter, it is now at 11 meters. So that means x is at 11. So we can sub in our x value into our equation and solve for y so we can figure out what the height is. So we're going to put an 11 in for x. So negative 0.38 times 11 minus 10 squared plus 40. 11 minus 10 is just 1. And 1 squared is just 1. So our equation becomes y equals negative 0.38 plus 40, which is 39.62. So the height, and hopefully that goes away, therefore the firework explodes at a height of 39.62 meters. Now the third question was, at what other horizontal distance is the firework at the same height as in part B? Well, remember, because parabolas are symmetric, um, the firework is going to be the same height 1 meter before the maximum point. Because in part B, we looked at the height at 1 meter after the maximum point. So, because parabolas are symmetrical, the horizontal distance of 9 meters, it will also have the same height as in part B. Okay, the second type of problem we're going to look at today are profit problems. You're going to see these in various math classes as you go forward, and you might also see these in economics and business courses. So this is good practice to see these problems now. So here's an example. Let's say the profit of used car sales can be modeled by the equation P equals negative 2 times n minus 200 squared plus 450,000. Okay, in this case, P is our profit and n is the number of cars sold. So part A is going to ask what is the maximum profit possible. B is how many cars need to be sold to achieve this profit. C, what is the profit when there's 100 cars sold? And D, how many cars need to be sold to make a profit of $300,000? Okay, so let's go through these one at a time. So question A, what is the maximum profit possible? Well, remember, this equation is in vertex form already. So the vertex of this equation is 200, comma 450,000. Now, because our A value is negative, that means the parabola is facing down. So that means our Y value gives the maximum value, and that is the maximum profit. So therefore, the maximum profit is $450,000. So for part B, how many cars need to be sold to get this profit? Well, the vertex of the equation is 200 cars sold equals a profit of $450,000. So that means the x-coordinate of the vertex will give us the number of cars needed to be sold to achieve this maximum profit. So therefore, the number of cars to be sold to get maximum profit is 200. Okay. So part C, it asked, what is the profit for 100 cars sold? So in this case, we're going to replace N with 100 and then solve for P. That's going to be our profit when we sell 100 cars. So the equation becomes negative 2 times 100 minus 200 squared plus 450,000. 100 minus 200 is negative 100. Negative 100 squares is 10,000, and 2 times 10,000 is 20,000, and Because the 2 is negative, the first part becomes negative 20,000. And then the last step is to add negative 20,000 plus 450,000, and that gives us a profit of $430,000. So therefore, the profit will be $430,000 for 100 cars sold. The last question was how many cars need to be sold to make a profit of 300,000? Similar to part C, we're going to plug in this number into the equation and solve for the other letter. But this time we're solving for n. We're solving for the number of cars sold and we have the profit. So we're going to sub in 300,000 for P and then solve for n. So that gives us 300,000 equals, not double. I'm just going to exit out and edit that because that's going to drive me nutty. Okay. So we've plugged in 300,000 into our equation. Now we have to get n by itself. So the first step is to subtract 450,000 from each side, gives us negative 150,000 over on the left. And now the next step is to divide both sides by -2. So that gives us 75,000 on the left and n minus 200 squared on the right. The next thing we have to get rid of is the squared. So we're going to square root both sides. So on the left, we get 273.9 equals n minus 200. To get rid of that 200, we need to add 200 to both sides. So 473.9 equals n. You may be tempted just to write down we need to sell 473.9 cars, but we can't sell 0.9 of a car. We can only count cars in whole numbers. So to achieve a profit of 300,000, you would need to sell 474 cars because 473 cars wouldn't get you enough to get to 300,000. So we'll have to go over a bit. Okay, so that's it for today. I've made up a quick practice assignment. There are 2 questions of each type, so 2 of height, 2 of profit, and I have provided the answers for you so you can check them there. You can also use Desmos to check your answer. That's a great idea too. Once you are feeling comfortable with those, go ahead and do 5.6 quiz on Brightspace. If you have any questions, please let me know using the envelope icon in the top right corner of Brightspace. All right, that's it for this unit. Bye-bye.